All right, we're going to look at downloading data on NFL performance. I've already done a little bit of work here, but literally only like the first 30 seconds, besides all the stuff leading up to that. So here's the story. ESPN used to have an API, which probably used to be awesome, but now it does not exist, and that's not going to help. They do have some pages on statistics, and maybe we can get something useful out of this. Maybe, um, but mostly, let's see, what is this? Maybe this is going to be useful. Quarterback rating. Ah, all right. So maybe we get something. Maybe we come back to this. But long story short, without an API, we're going to have to do this kind of the hard way. Now, fortunately, there is another source, and this is what I've looked at so far, which is just from NFL.com. So we don't have to go just ESPN, although there might be other stuff. Let's see. So this is just TV, nextgenstats.nfl.com. Maybe has something. Looks like this is sort of more along the lines of kind of some advanced stuff, right? This data, of the player paths is really interesting, but not something that we'll probably be dealing with in an introductory R class. I did poke around a little bit to see if I couldn't find some useful tables, and I don't know, maybe this is useful, but again, this seems to be more about the plays themselves and less applicable, less directly applicable to the question of picking a good running back for your fantasy team. So here are the two tables we're going to look at, or the two sorts of tables we're going to look at, the ESPN tables and the NFL tables. And let's take a look at what I've done so far and see what we can't build off there. So first off, I load in two packages, Tidyverse, because I always do, and RVest, which is going to allow us to scrape this URL to actually get some data. So what I did here is I just Control L, Control C to grab the URL, and then I put that into quotation marks, and I say, let's give the name passing underscore URL, because this is our passing data. Right now, I don't actually need that because I've already got it, but I load that in. Actually, let's even set up a little bit. Remove list equals ls. Load in our packages, load that URL. And then we take that URL and we get a page out of it. Actually, we don't. This is useful for prototyping. So let me walk you through a little bit of prototyping. And then I'll show you how I'm going to streamline this a little bit. So on this page, I've got just this one big table. Now, I do want to see what goes on after here, but I'm not going to figure that out just yet. So when I load this in with read underscore HTML, that gives me the page itself, right? So all the information about this page is wrapped up in this thing we're calling passing page. And what I can do with passing page is I can start creating a pipeline. So in this case, what I did is I said, all right, let's get the passing page and then let's just kind of check around. And this is literally just my first attempt at this, having cursory knowledge of this. So you put a little bit of time into reading RVest, I'm sure you can find a better way to do this, but this is good enough. Good enough for me anyways. So I get my page and I ask for HTML underscore nodes for a table, and I get this result. Right? Table class equals D3, yada, yada, yada. So I can do a little bit of snooping and figure out that they're using the D3 framework. I think that's JavaScript. The Canadians show on JavaScript. Data-driven documents is a JavaScript library for manipulating documents based on data. So whoever made this page made it with d3.js. That's fun to know, but we don't need to know that. What we need to know is there's a table in here. All right, so, and there's a function called HTML table that will spit this out. So, given a URL, we read the page. Given the page, we look for the nodes named table, and given the one node we found named table, we pipe that into HTML table, and we get this. And we could go even further, and we could change this a little bit. We'll call it passing table. We'll call it passing table 1. And all that is, oops, we don't need 2 pipes, is this, right? 3 steps. We read the page, we look for the table node, and then we do HTML table, and that will give us passing tables. Let's run through this again. There's our URL, and there's our table. And let's take a look at that table. Right now it's in there as part of a list, but what I've got is information on player, passing yards, yards per attempt, number of attempts, completion, completion percent, touchdown, intercept, I'm guessing. I got a bunch of data. I got a bunch of cool data. So let's grab from the next page. So this is, I don't know, hopefully there's not too many in here, but 2, that mess, and then I can say passing underscore table 2 is read underscore HTML for URL 2, pipe that HTML underscore nodes for table, pipe that into HTML table. Actually, I wonder if I can even do this. Let's try read underscore HTML for URL 2 into HTML table. Get it? Oh, wow. I don't even need to go through that node step. And this goes Nick Foles down to some other guy, Jarrett Stidham. All right, cool. So we're getting this data. Now, what's going to be useful? One is we don't want to have to keep doing this code. Well, we've saved a little bit, right? We're just saying read HTML, pipe that into HTML table. But even that is really more than we want. What we want to do is we want to take this, get out the information that we're putting into here, but pull it out of the list item. And then we want to join it with the stuff from the other. And then even better, we want to just pass in a bunch of URLs. So I'm going to make a URL list. And now list factor, whatever. We'll do it. We'll do it as something, right? But more important, I'm going to wrap this into a function. That function will take a URL and will spit out the data, right? So we'll call it grab table is a function, and let's just specify, we're going to call it grab table NFL because we're looking at the NFL data. So we're going to take a URL. We are going to pipe that URL into read HTML, which we will pipe into HTML underscore table. Let's call that out. And then we will return item 1 of out. So if I go grab underscore table underscore NFL for that passing URL, I get these first 25 players. And if I say pipe that into full join with grab table NFL on URL 2. Whoops. What do I get? I got 50 players. Jarrett Stidham is the last one. All right. So we've got data, right? Let's tidy this up a little bit and then think about sort of a kind of hacky way to repeatedly do this. So first off, I've got this function, which I like. I'm going to put this up near the top. I'm going to call this URL1 and URL2. Okay, whatever. I guess I don't need this. There we go. This is saying after cursor, a whole bunch of letters and numbers. Not really seeing any hints. It'd be really nice if this just said, after 25. Then I could just kind of repeat the pattern. All right, let's clear it out again. Grab table. We got URL1, URL2. This up a little bit as we go. So what's this going to be? I guess it is grab table. Do this. I think we can do a map underscore df where we map over the URL list and pipe those into grab underscore table NFL. Let's see what we get. Passing table 50, perfect. That looks just about right. So here is something that's a little bit easier. Let's see if I can even do this. And actually, let's see, I'm going to even skip a step. Right, I don't need to name this thing URL3. So if I take this, all right. Okay, so clear it out. Just make sure that everything works. And then I'll wrap this up within the next minute because 15 minutes is too long to watch me just solve problems. All right, so I think this was our third page. That looks the same as the one above it. So we'll go next page. Just going to see how many pages I get. I'm going to plug those pages into here. Oh, looks like I don't even need that page. Let's see what happens. Just for kicks. And this is URL underscore list. So I've got my function. that takes these URLs, and I'm going to map this function over these URLs. So I'm going to apply this to this, then this, then this, then this, and I'm going to spit out a data frame as the final object, and that data frame is going to effectively just be a join on what we would get by running this on each of these URLs one at a time. So, subscript out of bounds. So I think that has to do with that last one not having data. So let's just get rid of that last line. Let's try it again. All right, cool. So in this case, 75 players. Oh man, ads are stupid. Why is the NFL getting ads through my ad blocker? All right. What am I looking for? How many running backs in the NFL? I want to make sure. I mean, 75 seems plausible, ranking all 32 starting running backs. So we got 32 teams. They're each going to have some number. Seems like a lot. This is colleges. Draft history. Let's see, I don't need this D3 page anymore. Oh, I said I'd finish in a minute and a half ago. All right, let's really quickly take a look. 50. What happens when we show more? 100. Oh, wait. This is QBs and running backs. Okay, well, in any case. Oh, this might be nice also. Okay. So what have we got, and what can we do with it? I'll wrap this up within 20 minutes instead of 15. All right. So we've got a way to take a URL and pull out the table. That by default spits out a list, so we've got a way to pull out what we actually want. Right? So this is just a really simple little function that I built, really to just kind of do two things in a convenient way for me from the NFL site. But something similar should work for the ESPN site also. Let's just really quickly check there. Grab table NFL on this. What do I get? Cool. So actually that is kind of helpful also. This one will require an extra step. And actually it's going to require at least an extra step. That's weird. Well, what can we do with this? So I do like the NFL page a little bit better, but you might go through some of these steps to make it work for the ESPN data. But what we can do is we can say, let's go through our finite list of pages. So we'll get a rushing page also. It's simple enough and it's small enough that probably it's easier just to kind of get those URLs, manually do it, download the data, and get it all together. So what are we going to have with that? We're going to have this downloaded data. And actually, you know what? We might even be able to take just with this. Let's throw this in here also. So as you get this data, you can join it together and build a larger and larger data set. So right now I've got a data set with 75 objects with 16 variables. Let's see what happens when I throw in that rushing page also. I should get more observations and more variables. Great. So if I look at my passing table, not my passing table, you can already see I've got a bunch of NAs in there for where they're missing data. So if I look at the end, I'm guessing I'm going to see some data for that stuff, but then I'm missing stuff otherwise. Here's what I expect. I think that if you do a passing table and a rushing table, where you do something very similar, right? So let's just comment that out. We can call this the passing list. Update that here. And then we can do something similar, map df for the rushing list, using that same grab table NFL. All right, so 75 of 16, 25 of 10. Let's see what happens if I just merge them. Merge the passing table and the rushing table. Looks like it didn't work. Let's try full join. Full join as Tibble. All right, so it's still 100 rows. I guess no one in here is also showing up in the passing. Okay. There, 20 minutes just passed by again. Let's wrap this up. I'm going to upload this as kind of a rough draft, and then I'll do a shorter version well, later when I get to it. But what we can do with this, we assemble those URLs kind of in a hacky way, but it'll do the trick, right? It'll get us moving. So you get that data, or you get those URLs. You assemble the URLs for all of these different things. You put them together in lists, and then basically you're assembling the data by taking each of those URLs and grabbing the table from that page using Arvest. So it's going to take a little bit of time to download, but it seems to be working. It seems to work well enough. And then what we can do is we could say, you know, all the data could just be, say, a full join of the passing table, now, and all your other tables. You do that 2 at a time, but then you say, all right, so we join those 2, and then we full join the tackle table and whatever else, right? You just go through. So what that will do is, hopefully, if there are any players who are on more than one of these pages, right? So you might have punts and field goals. You might have the same people show up in multiple places. I don't know. Maybe we do, maybe we don't. Maybe you don't need all of these things, right? So tackles, you probably don't need that for finding your running back. But using that full join, what it's going to do is it's going to look for player names and it's going to try and match them up, hopefully. Now, that might be another problem, but let's take a quick look at what we've got for sure as a starting point, and then I'll try and make like a 5 or 10 minute version of this same video to kind of give the TLDW version of that. So we are using tidyverse and Arvest. We are using a little bit of code, a little bit of Arvest code, but we're going to wrap that up in a function to make it easier to reuse. We've got some URLs that are going to the pages that have the tables that we care about, and we can grab those tables using map. All right, so we are mapping this function over this list of URLs. Really, it's a vector of URLs, but we are assembling this all together, and the result is that we get 75 observations for players passing stats for 2020. I'm going to take a quick look, 2019, just to see what we get. Let's see, this still has 2020 in the URL. Should be able to get I should plug in 2019 manually and see what I get. 2019, okay, well, whatever. At the very least, we've got a starting point. And that starting point is you get those URLs that were working, right? So we go to the 2020 data, and we're just grabbing the URL from the page. We are putting it into this vector. I'm putting it into the vector because I just want to loop over that vector. It's a lot nicer than, say, repeatedly applying this 3 different times and then joining everything. But we get those URLs, we pull them together, we got some data. Now with this data, there's all kinds of stuff we can do. So let's take a really quick look at that passing table. So we got these variables, and let's say we want to predict pass yards based on, say, attempts. So we can take our passing table and we can pipe that into LM. And let's look for pass yards, which I think in backticks deals with that space. Pass yards as a function of attempt. And our data is the passing table. I guess we don't really need to pipe in this case, but let's just see what we get. All right, cool. So we're getting something. So this particular regression, it's not a great regression, although, wow, that's a pretty good R squared. The more attempts you make, the more yards you get. Not terribly surprising, but surprising just how much variation is explained purely by the attempts. All of this to say, this is the code. I mean, you're going to have to find some URLs, but this is the code to roll together a bunch of stuff. I'm going to scratch that and just think, all right, you pull that together. Once you got that, then you're on a different part of the project. All right, I'm going to throw this up just so I've got something up, and then I'm going to put up a more condensed version where I explain a little bit less along the way.